non-inverting, because input signal here is connected to the non-inverting terminal, that is positive terminal of the op amp. Here is also it is in non-inverting op amp configuration. It is unity gain op amp. Okay, so this two op amp will be good enough to give a good sample and hold circuit. And here is a hold capacitor and this switch. This switch may be realized with BJT or mostly realized with FET. Okay, so a control logic will be generating a signal, and that will be connected to this gate, and this will be made on or off. Basically, that is the idea. Okay, so the typically the sample hold circuit is the limiting factor for the speed. The sample time may be due to this sample and hold circuit and or comparators. Acquisition time, aperture time, and group rate are the design metrics of sample and hold circuits. Okay, sample and hold circuits. These are the few terminology you have to remember. What are those? Acquisition time is what? Aperture time is what? And group rate is what? Okay, this is related to sample and hold circuit. Here, the same sample and hold circuit is realized with a switch and MOS switch, and this is coming from some control logic, which is going to give control signal to this MOSFET to make it on or off. And you have the op amp 1 and op amp 2. Why these op amps are used? Why not only the switch and the hold capacitor, having a value of 100 picofarad to around 1 microfarad, depending on the requirement. Okay, so what is the purpose of sample and hold circuit? Is it understood? What is the purpose? Aman?
Yes, understood.
So and sample and hold circuit is used to sample an input signal and store its value for some length of time. It finds its application at the front of ADC, analog to digital converter. The output of the ADC will be ambiguous if the input changes while conversion is taking place. To get around this problem, sample and hold circuit is used. Okay, when the converter ADC, analog to digital converter, is converting, during that time input should not change. If it is changing, then actually you will not be able to say what is the value and output value and whether it is correct or not. So the first op amp, this one, offers high input impedance to the source. Source may be here, signal source, any signal source, maybe mic or any transducer. Okay, so it is going to offer a high input resistance. We know that it is required, otherwise it will be a lot of precious value of this signal will be lost. Okay, and we have understood at the beginning of this course. The second op amp offers high input impedance to the sampled, this capacitor, sampled signal and in hold capacitor. Therefore, they avoid loading effects. If you have high input impedance here and here, then loading effect will be not there. And we have understood this thing. They are used as unity gain non-inverting amplifier. Configuration itself is saying that the switch is implemented with an MOSFET gate electrode of which is controlled by a clock. This may be, as you have seen, that some logic circuit is going to supply that clock-like input to this gate. Okay. The definition about this acquisition time, aperture time, and group rate. Acquisition time is the time required to get an accurate sample. It is ideally 0, but due to finite channel resistance, MOSFET is having channel resistance. You know, any MOSFET will be having channel resistance. Current has to flow through this channel, and it is having some channel resistance. After all, electron is flowing through semiconducting material, and semiconducting material is not a good conductor, so resistance will be there. So due to the finite channel resistance and charging time constant of the whole capacitor, it takes some acquisition time. Okay, immediately you cannot sample it. Some finite time is required. Then aperture time is the time required for the MOS switch to open. Open or close, both takes a little time because charge has to flow. So suppose your MOSFET, and in the channel you have charges. No, charges will be there, electrons will be there. When it is on, charge carrier is flowing, isn't it? And this instant you are making it zero, for example, it is on MOSFET, it is making zero. During that time, see, charge is there. Okay? Charge is there, here to here, a lot of charges are there. That charge has to go out of the channel region, then only it will be off. So it takes a certain amount of time. This time, due to the channel charge, the MOSFET switch takes a certain amount of time to be off. Droop rate is the rate at which the output voltage decreases of the whole condition. I mean, your capacitor is holding some value, whatever input value that is stored. Okay, but you know, BJT or MOSFET are leaky. They'll be always leaking. Some current will be leaking into the body of the MOSFET from the drain, and hence a leakage will be there, and hence it will be dropping. The value of the capacitor will be dropping, and that drop, how fast it is dropping, that will depend on the value of the capacitor. If it is small capacitor, it will be dropping quickly. If it is huge capacitor, it will be slowly. Of course, it will depend on the acquisition time also. It is related to that, related to the capacitor value. The switch is this is why output voltage droop slowly when the switch is open. The larger whole capacitor, the smaller the droop rate in a given time. The smaller the whole capacitor, the shorter the acquisition time. You know? But the higher the droop rate. So it is related in this way. Okay. Drawback is there. First, dropping will occur. That is not desirable. Droop rate, higher droop rate is not desirable. If you want to make longer droop rate or slower droop rate, then you have to make the capacitor higher. And if you are higher value of capacitor you are using, then it's good. It will not be drooping quickly, but acquisition time will be more. Your charging up will take place and it will take longer time. Is it understood, Aman?
Yes, sir.
This diagram is given in your book with example of op-amp LM102. Basic circuit is sampler load is this one only. And in addition to that, if you use one or two op-amp, then it will be better. Okay. A sampler whole circuit is in its simple form is switch S with capacitor the C or C hold. The voltage across the capacitor tracks the input signal during the time t when a logic control gate closes S. This is closed, means on, and holds the instantaneous value attained at the end of the interval t when the control gate opens switch. The switch may be a relay for very slow waveforms, a sampling diode, bridge gate, or bipolar transistor, or MOSFET. And MOSFET is the mostly used nowadays. The circuit shown in figure is one of the simplest practical sample and hold circuits. A negative pulse is a P MOSFET. So negative pulse at the gate of P channel MOSFET will turn the switch on, and the holding capacitor C will charge with a time constant R on. R on is the resistance of the MOSFET, and C is the capacitor value, and this together is time constant. So to charge up the capacitor, whole capacitor, it takes certain amount of time, and that is given by R on C. In the absence of the negative pulse, the switch is off. That is, this is off, not connected. PH is not connected to this point, and the capacitor is isolated from any load through the LM102 op-amp. Thus, it will hold the voltage impressed upon it. It is recommended that a capacitor with polycarbonate or polyethylene or Teflon dielectric be used. I mean, good quality capacitor is required to be used. Most other capacitors do not retain the stored voltage. That's why author is recommending those capacitors. Due to the polarization phenomena, which causes the stored voltage to decrease with a time constant of several seconds. Even if the polarization phenomena does not occur, off current of the switch of the order of 1 nano ampere. As I said, that MOSFET are having leakage. MOSFET structure I have drawn several times, and I have said that you have a reverse bias diode. Reverse bias diode. Where the reverse bias diode, can anybody say?
Yes, sir. Near the drain side.
Yes. Here you have the reverse bias diode. Am I correct? Yes or no?
Yes, sir.
So you will have the I0, or you can say IS, whatever you want to say, reverse saturation current. I0. Reverse saturation current